then we can move on.
She's saying I'm wrong, teacher. I don't think I'm wrong.
So, well, this was a conversation that, that we actually had, during your break, with Dr. West and Laura. Ashley, and then I'm done. Go ahead.
I was gonna say, but the thing is, in 5th grade, we call them particles, and we don't get anywhere near saying atoms or molecules or compounds, but they have to know what solid, liquid, and gas are,
But we,
and how they act.
I mean, we, in 5th grade, we can say molecules, but we just don't go to the atomic structure of matter. We don't talk about.
But you can say anything, it's whether you should.
Right.
So should you say, and I don't know the answer, I'm thinking through
Right.
this as we're
Right.
talking here. So should you say particles instead of molecules?
I
Because
say
Or should
yes.
you use them
that's what you're
interchangeably?
developing. Pardon?
Should you use them interchangeably?
I think I think by saying atoms and molecules, you start opening to the door of something that you can't get into, and they're gonna start filling in their own blanks. And that's dangerous.
Yeah.
So, we could say particles, but, like, Tim, what you're saying is like understanding what an atom is and the structure before you can understand solid, liquid, and gas, it's like, well, no. We can talk about particles and how they act whenever they're in a certain state.
Most of
Yeah,
our,
teacher's just saying I'm wrong and I don't think
Yeah, so I need an answer on this.
most of our models of solids, liquids, and gases are made up of like little circles.
Right.
And a particle.
Right, a particle,
Mhm.
right.
Laura?
Just, can you clarify, we're saying, was there more than one concept in this lesson?
More than one
What-
concept that you, okay, go
But
ahead.
what's to say that this wasn't 2 lessons back to back?
That's what we don't know.
Right.
So just is one lesson, so.
Okay, so you helped me. So because that's what I was telling Ashley, that I think this was multiple concepts, but there were also multiple lessons. So like the first one, when you were talking about compounds and elements, and then we closed that out by if you truly understand, before you went on to the next lesson, which was a different concept. That's how I looked at it. So there were multiple concepts, but there were multiple lessons, so that's okay.
I can see that whole time taking a week, especially the way it was structured, there was an inquiry, and,
No, you wouldn't have done all of this in one class period.
Right.
There's no way.
Well, it has more classes for me, so that's why it's one lesson for me. I mean, now when you talk about the 5, I'm like, oh yeah, so we did end it, and then we started lessons, but I didn't see that, or, yeah, to me it's all one lesson, cause it happened back to back.
One period.
Yeah.
so which one?
What is the answer?
There were multiple lessons, but one concept per lesson.
So one concept.
One
So
concept.
Tim was right?
No,
Yeah.
Tim was
Tim
wrong.
was right.
Tim thought this was one lesson.
I didn't think it was one
Tim
lesson.
said one lesson.
I never said it was
He
one
said it was
lesson.
a concept.
said it was one
Okay, give me 5. Okay, Laura?
So I think what the confusion is that is a lesson defined as a period of time? Or is a lesson defined as, like, would you teach solid liquids and gases while you were teaching the molecules and compounds? Were they done at the same time and the same activity? Or were they separated out?
I thought that it was one lesson, and in fact, on this slide here, right here, I wrote new lesson, because to me, I didn't feel like, I felt you didn't have the understanding of the atoms, molecules, et cetera, before you went on to states of matter. And so the way we are defining a lesson is not a period of time, it's not like a period, like a 45-minute period. You could have 3 lessons in a period. It's a matter of having a full cycle so that students end up with most students end up with a good understanding at the end of the lesson, whether it's 15 minutes or whatever. So by that definition, I said this was a new lesson when we went into states of matter. Yes?
Well, that brought me back because the states that matter, I remember even, so now let's go back. So that's why I thought it was one lesson too, because we went back to finally get the actual definition.
I don't think it matters so much as defining it one lesson or two. I think it's more of, is there a complete understanding before you go to the next concept?
You know what I'm saying, cause there wasn't so we didn't clarify that one lesson.
Right.
We went on to the next one, and then we
Right.
had to go back to that lesson.
Right, and so that was why I said, no, I think this should be divided into two lessons, two complete lessons, so that there's a clear understanding of atoms and molecules and what else we do, elements or whatever, before going on to states of matter.
Well, my question is though, so some of us didn't quite get the molecules and compound, the difference between those, or how the hierarchy, whatever. And that happens in the classroom whenever, especially, general ed classroom. So if you've got a small portion of the class that just not happening, but you need to go on whenever the majority, more than 50% of the class is ready to go on. I mean, how do you gauge that? I just don't know.
I wouldn't say a majority is 51%. If you got 50% of your class still does not understand, and that means something is wrong with the lesson. It did
Okay.
not teach
Well,
what
let's
it
say here,
intended to
but-
teach.
Going back and
I
clarifying.
think it's gonna be depending, the percentage, I think depends on your particular class. It may be 85% in one class and 75 in another class. Not for grade 5, because y'all just gonna have one class.
Right.
But if you had multiple classes, so I think it's hard to put I think it's difficult to put a hard and fast rule on some things, and it's just that teacher, the art of teaching, that you've gotta make decisions about. What, Laura?
I think you also have to figure out why they're not understanding. Like in physics, when I have a concept that is heavy math, 2/3 of my class might get it because they are in higher level maths. So I may need to go back and teach it a different way with the other third. So it might not be that, it might be just meeting different needs of the kids rather than there's something wrong with the lesson. I mean, maybe that is a flaw with the lesson.
Well, I think as
Or
teachers,
maybe
that's the first thing we have to do.
pre-teach.
I think the first thing we've gotta do is look in the mirror.
Mhm.
What is it, what best practice, or plural, are missing from this lesson? If I see students not understanding, I have to go back and look at myself. What's wrong with this lesson? Well, how could I have made it better? And in fact, one of the notes, I take notes on these things. So one of the notes I wrote on here was the difference of what we call multiple representations. So if we have multiple representations of a concept, for example, you might take H2O like that, but would also look something like this, so. Oops, sorry. So in other words, think of different ways that one concept can be represented, and usually, if you have multiple representations, this is only two, but if you have multiple representations of a concept, it's gonna, you're gonna get the first one, and you're gonna get the second one, you're gonna get the third one, and so on. Or, this group gets the first one, and this group gets the second one, et cetera. So you have to have multiple representations of a concept. Laura, do you wanna say anything?
After Candace.
Candace,
you
it's
know?
yours.
I have one more thing while Laura's getting up here that I noted. There were some very, very good applications, like the balloon and was it a soccer ball? Brandon, where are you?
It's not here. The
Basketball.
Okay, some kind of ball, I couldn't hear what kind of ball it was. So those are great if we can have applications that are real world, so to speak, they're real world. But the other thing that I heard that is misleading in kind of in a way that you wouldn't suspect it, and that's the anthropomorphism of natural events, natural phenomena. I heard, I don't wanna be touched, which makes sense, okay? That makes some kind of sense, but it conveys to a novice, a child or adult, that there is a decision-making by these particles. Think about natural selection. 50% of adults do not understand natural selection. They cling to the idea that a characteristic of a species is there because the species needs it. No, the species is surviving because the characteristic is already there. They're, quote, born with it, if you would. They don't choose. And then there was another one that said, trying to move away from each other. No, they're not trying to move away from each other. They don't decide, oh, I don't like you, I'm gonna move away from you. That's not what happens in natural phenomena. They move away from each other because of innate characteristics of the particles, if you would. I know you don't say that to your children, but you understand what I'm saying? We have to be very careful about using those kind of statements, those anthropomorphic statements, yeah.
So should we say those things to get them to understand, like they do repel, but follow it up with, for a 5th grader, say, now do particles really say, no, I don't want to be next to you? No, they don't
Okay,
really
but your
do.
first language says they do repel. That was not anthropomorphic. But your question, I would agree with. Yes, you do have to be, you can't be too subtle with, certainly with children, maybe not even adults. But I think you're absolutely right. You have to come it right out and say that they don't choose, or they don't say, or, you know, whatever. Yeah.
Just to clarify, I was speaking as a student, but I guess it just kind of helped me remember what happens when particles get heated up. It's as if when I'm hot, I won't be stuck, or I won't be close to somebody. So it was like a student's way of, trying to, their own word, not their own words, but related. Because now when I'm cold, when particles, I want to get warm, so I'm gonna, connect to somebody. So in my mind, when they get cold, they want to be,
I'm just putting out a red caution flag because we see it play out in different ways and misconceptions. And part of that precision of language, that we've talked about has to do with things that we say. We've caught ourselves saying it. When I go to the PhD biologist seminars on Fridays, I hear them saying things like that, those kind of statements. But it doesn't matter because we know that's not what that language means. It actually has a scientific meaning. But your students do not know that, so you absolutely have to clarify, no, they do not choose to do this. They don't want to do anything. They move away because it is part of the nature of that particle or whatever we're talking about.
So you don't point out your colleagues' sloppy language when they say things like
No, we do not. Actually, we do call them out, but it has to do with science. It has to do with, inappropriate data, inappropriate analysis, or inappropriate conclusions that don't match the data, the evidence for their answer, et cetera. Yeah, they do get called out, but not for that. Lauren?
And on that topic, I think we need to be very aware not to choose lessons that make protons into Patty. Proton
It's positive.
is positive, and I understand that helps remember, but that they will. It's like assigning or humanizing these things, or what'd you call it?
Anthropomorphic.
It's easy for y'all to say. That's not scientific to me. Maybe it helps, but with 8th graders, I think we're beyond.
That's kind of in that category of tricks, the math tricks that we screw up math with, that we science people screw up math with, by telling them to reduce the fractions or whatever nonsense we say to them. Go ahead, Lauren.
Okay, this is
Can we
super
go
high
back-
tech.
Can we go back to everybody's seats? Yes, I can see that.
Yes. There's, I know there was an adapter for your HDMI
Yeah,
cable.
yeah.
but it's not up here.
That works, go ahead. I did that one time, I was in a meeting, one of my grad students did not put my dongle in, and all I had was a dot camera, and I had about 150 people in this room, I'm thinking, okay, I got an hour, I went singing and dancing, and I do. So I took my computer, and I actually flipped it, so the camera was looking at the screen like it is right now. It's a little bit of glare on there, but.
It's okay, we're gonna look at the teaks. And, Dr. West, do you wanna disperse? You mentioned.
No, go ahead.
Okay, all right.
We're just showing you some of the changes in the streamline.
So this is the old teaks and the streamlined teaks. So the student knows the differences between elements and compounds. This is grade 6. The pink is the addition of, this is what was added to this teaks, this is what was removed. So A says they know that the element is a pure substance represented by a chemical symbol, and that a compound is a pure substance represented by a chemical formula.
So H2O would be a compound. It is a pure substance that's represented by the H2.
That makes sense.
Does it?
Yes. So that chemical symbol, oxygen, O, and a compound, water, H2.
Oh, wait.
Chemical.
Okay.
Now there's pure substances up there twice.
Mhm.
I didn't realize that a second
It
ago.
says that an element is a pure substance represented by a chemical symbol, like H or O. And that a compound is a pure substance represented by a chemical formula.
Think this through carefully.
Y'all just let that sit in your mind for a minute. I'm just waiting for somebody to say something.
Well, I think this is, that's still pretty abstract.
Yeah.
I mean, the abstraction of saying, oh, an element is represented by a symbol, but there's not any, for me, when I read that content strand, it does not convey a conceptual understanding of element and compound like we did today.
Okay. Kim?
Chemical formulas, we don't discuss that till 8th grade, why are they pulling it into 6th grade too?
Sixth grade thing where you're filling out in sixth grade.
So
But
we're now adding
the
chemical
old-
formulas?
Wait, the old C says differentiate between elements and compounds. Ashley?
So, again, as 5th grade being the highest pay grade I've ever taught, studying and just things, but we keep saying pure substance, and by saying something is a pure substance, to me that implies that something is impure. What makes something impure? If you're gonna use the word, it's a pure substance, so what's an impure substance? Why not just say something's pure?
It's a non-example.
Wait, what?
What is a non-example?
What is a non-example?
If everything's a pure substance, what's a not a pure substance?
A mixture?
Or isn't that what a compound is? A mixture is.
No.
We're talking about homogeneous,
Homogeneous is, I think what they mean by pure mix.
it's the same all the way.
So,
Oh,
let me ask you this. An element is a pure substance represented by a chemical symbol, like H, or O, C, BE, TI, HE. Are you with me on that? Okay, let's go to part 2. A compound is a pure substance represented by a chemical formula, like H2O or NaCl or O2.
O2, which is a pure substance and is also a chemical formula.
But what is it not?
Yeah, what is it not?
That's why we're at
It's
the
not a
sixth grade
compound.
level.
It's not a
What, Kim?
it is not a compound.
No, it's a molecule. It's a molecule.
It's a molecule, but it is not a compound. A compound is two separate,
Two different.
two different, a green Lego and a red Lego.
So salt is a compound,
Correct.
but it is a pure substance, because when you put these things together, all you have is salt.
That's not what she's saying though. She's saying that if you
Compounds,
have O2, an oxygen molecule made out of two oxygen atoms,
it is
then
not
it
a
is
compound.
represented by a chemical formula, O2. Would you agree?
Yes.
Okay. This TEACS tells us a compound is a pure substance represented by a chemical formula. O2 is a chemical substance, a chemical formula.
It's a pure substance represented by a chemical compound.
It is,
But it's not a compound.
but it's not a compound. So,
The T is miswritten.
that is the what?
Is that miswritten then?
It is
Ah.
poorly composed.
Poorly.
Some might say it's wrong.
Yeah, poorly composed or wrong.
So is it important for you to know your stuff and not rely on just what's written here? You need to know way more than what you are called to teach, what standards you're called to teach, because that's not, that's like the rectangle and the square thing, right? Rochelle?
So how could that be written, I don't know, correctly is the right word, but
I tell you what, middle school, let's us work on that, because that's not fifth grade. But the point that Laura was trying to make is, you need to know your content well enough to be able to recognize a problem like this in the TEACS. The TEACS are not perfect, and so you need to see what holes are there. I think they've made some holes. This is a mistake, it's not just a hole, but you need to know it well enough, so don't, have confidence in yourself. You know, you may not know the answer, but you know where to go to get it. In science, of course, the standards can help with that. Math, I'm assuming they can too.
Question, how could this be, you know, on that wonderful test that we all love so dear? How, because I could see how this could cause them a lot of problems in testing.
But 6 isn't tested. It's science.
No,
Yes,
but
it
this
is.
TEAC is tested in eighth grade,
Right. But
what they learn in sixth grade. So my question is how would that, like, how could they word a question that, like, how could you,
Could we talk about that in middle school?
Yeah.
Primarily, it has to do with their examples that they're gonna use, so.
Yeah.
it's our question. It's our question.
Okay, here are, let's see.
No change there.
Okay. Another change in 6th grade. The cycling of matter in living systems, wait, that's 7th grade.
That's 7.
Yeah, that was taken out.
So composting out, doesn't mean that you can't teach it, it just means you're not gonna test on it.
It's no longer tested on in 7th grade?
It will no longer be, remember, these don't go into existence until 18, 19.
Oh.
Yes,
So was this the recycling of matter and composting, was this not part of a 7th grade TEAC, which is why they pulled it out of 6th grade?
No, this is, that's
This
a
is
different
7th
grade.
grade,
These
7th
are
five.
7th grade.
yeah, but
I
this is
know
seventh.
it
Okay,
That was.
thank you for the clarification.
Yeah. Okay, and my question is, I rely on students really understanding that to then teach the law of conservation. you know,
And
later.
then it also goes with the whole food webs, like food change, I mean, as bad as it sounds, it's always where they get their.
Okay. Okay, that's still 7, so in 7th grade, the whole organic compound thing was taken out. Physical and chemical changes in the digestive system, and the breaking down of large molecules into smaller molecules,
Oh,
taken out.
if they break that down, if they take that, then how am I gonna teach them photosynthesis?
You're gonna teach them.
Yeah, that means you're gonna teach what's left over. Actually, that C is not that hard to teach. I mean, even at 5th grade,
They don't have that.
if you're talking about carbohydrates, a carbohydrate is like a train. It's like you got a sugar bonded to a sugar bonded to a bunch of sugars, that's a carbohydrate, right? That's all it means, it's just that this is a large molecule called a carbohydrate, and it's just got a bunch of sugars bonded together. That's all there is to it, yeah.
I know, I'm just saying that I'm gonna have to spend a lesson on that instead of, you know, I'm gonna be teaching a lot more in 9th grade. That's cool. Okay.
Well, just think, between 7th grade and 9th grade, they're gonna sleep a lot. So you get to start with a clean slate with no misconceptions.
They can't be.
I'm trying to make it feel good.
I'm just thinking about, you know, breaking, like, getting everything in before that STAR test and panicking. Time frame. Good.
Okay, and then 8th grade.
That's a good thing.
8th grade right here, the only one that was changed in this section is the removal of recognize whether a chemical equation containing coefficients is balanced or not, and how that relates to the law of conservation of mass. So the law, that cycling of matter was removed, that's the law of conservation of mass. It was removed in 8th grade, so that is consistent, I guess. But in E, the conservation of mass is there. So in chemical reactions, I guess you're not looking at the equation to illustrate the law of conservation of mass, but you are looking at the reactions. Yes, ma'am?
Can we have maybe a discussion about how, I know that content strand was taken out, but if you look at the NGSS standards for middle school, there's a performance expectation that says develop and use a model to describe how the total number of atoms does not change in a chemical reaction and thus mass is conserved. So I'm wondering how that would look in a lesson, but we can talk about that later.
Yeah, cause that's what they took out.
But when you model a chemical reaction, investigate how evidence of a chemical reaction, when you're modeling that reaction after you investigate it and observe and infer, you can model, we took this with your math blocks or Legos, and then it was rearranged, those same things were rearranged to create a new substance. So while you're not balancing it, you are modeling that what you started with was just rearranged to make a new product in the end.
I haven't looked at the, grade 5, have y'all looked at the streamlining with grade 5? I haven't looked at that, to see how much different that is. Ashley was on the K2 team, I guess it was. She probably was more familiar with it, so we could have that with you guys only. Okay, it's, lesson planning time. I would like I wanna know how many, have y'all finished with yours so that you're into your Lockhart format, putting it into your format yet?
Yes.
That was the easy part?
Well, it's still pretty in-depth with
coming up with your 5E and, you know, the various measures.
Okay.
So we have not finished that, the 5E
Okay, well,
model for
let's set a
that.
goal today, so that Wednesday, when you come back, you're going to be able to take, pretty good amount of time, maybe 10 minutes or so to describe your lesson, so you're kind of presenting what your lesson's gonna be on Wednesday, everybody? Yes, ma'am.
How detailed do you want our description, because I have written down by slide what I want. Do you want that detailed, or do you want just an overview when I present on?
If I were you, I'd start putting it on in a PowerPoint.
Okay, that's, yeah, I was gonna get PowerPoint today.
Yeah.
But
I actually, that's how I plan. I do, I can go through the lesson and see the flow of it better with the PowerPoint. But it's not the right way, I mean, it's just a way. It doesn't matter, as long as it comes out in the email.
Yes.
That's right.
So here planning, here's I'm about to make it. Okay. I'm not running well.
No, I'm here.
We're planning in different parts of the
So, am I planning with y'all? So on here?
Yes. And you could also say here, because Leslie doesn't have a computer.
I'm trying to figure out where to do that.
Where did y'all sit last time? Here? Oh, I'm sorry. I didn't
Move your churches, I'm just gonna. It's just easier.
Yeah, we can move some of this stuff on out of the, yeah,
I'm just gonna take this with me, so then I can figure out what I like. I got one of those. How did y'all decide your teams?
based on that school that you're in. You don't know yet. I think right here, that's where.
I'm gonna move it and then it's not all.
I was just like, so. Brenda was gone on Friday, Brenda was gonna be gone. But we started this on Thursday, but we knew she was going to be gone. I don't have to yet, so Gloria had to go right here and there. I'm not. Strong, and then you and I will find our way, and then I'm not sleeping. Okay. I'm gonna get back there too.
I'm gonna, I can see I can send it to her. So I'm gonna send her, do you have it with you? That I can send, oh my. Alright, so whatever, you want, I can send you what we've been working on.
Okay, I can tell you, I mean, it's just, it starts with my first name, A-R-B-E.
Do you wanna like write it and give me a copy? That way I can send it to you.
I mean, you can do it.
I can get the middle already. We have a full straight and I didn't put it back in the
So you need to have to break it down. I need to change these for I think that's something that is done. Like that'll be for what?
Maybe I'm starting to. Hey, can I move these trays?
Okay, here's how you spell my name, and then just at Lockhart, T-A, you know.
Okay, so you're at Lockhart. What school were you at?
Huh?
What school were you at? Oh, you were.
Good. I gotta work with the electives.
Nobody wants to work with me.
2x2 by myself. Basic would be 2x1, just so they can really make them do at
It's
least.
okay, I don't need a pity. Just be here by
Hey,
myself.
don't tell me who all over there.
Where did everyone go?
I'll bring my tablet tomorrow. I don't know how much I'll be able to do with it, but I'll bring it.
I had a student back, a delia. So yours is R-D-E-L? So hers was exactly spelled like yours, except no R. But do you go by Leslie?
Well, if there's no way to like today.
But it'll never get to me if you type Leslie Douglas.
It doesn't matter the water the last
Oh, good, that's one strategy. Just
So, were you teaching a different grade level?
I'm trying to hard to get I think we did department wise. I know. We weren't self-contained.
Sorry, that's where my money is right there. So, yeah, like, to my, something's wrong with me.
Taking a while to know.
What's the Wi-Fi here? I can read it on my phone.
Yeah, it's,
And you said you were emailing me something?
yes, but I'm having a very, slow connection. So,
I'll bring my tablet tomorrow. Okay. I mean, it's not as good as a laptop, but it'll be, I'm gonna look at it.
It's a lot, not exercising, and so I'm hoping had to adjust my britches.
What school are you at? Okay.
you're very healthy. Yeah, I didn't see that often.
No, because my brother-in-law did cookout, and he's like pricey, and I ate and I'm full. He goes, now try this other thing, and I'm like, okay, and I ate and I was full, and he goes, now try this. So I ate it. So I did a whole lot of cooking stuff, even after I was full, because
That's what we did on our vacations, like we'd ride, we'd eat breakfast, and then we'd ride down the road an hour or two, and oh, let's have these snacks, and then we'd stop to eat lunch, and then we'd ride a little more, oh, it's time for snacks, okay.
So I didn't exercise for 2 days in a row, but I'm like, yeah, so sad. I'm getting up today, so my nephew was sleeping on the pull-out couch. I just ignored him. Apparently he did not hear me, because I had to actually wake him up to get him to go to my room, and then I had to dump the trash and all that other stuff before everyone else woke
It
up.
should pop up because I already sent it.
Via email?
Docs, yes. It should come up on the email.
In dots.
I had
And did you send it to me? I can please, I can look at it an hour or something tonight.
I sent it via
I'll
docs.
bring that tablet.
I'm gonna Google docs. Forgive the smudges.
Did you add anything this weekend or, no, okay, good. Because I'm like, I didn't either.
What's not this one? This one.
If you look at.
Oh, here it is.
Yes.
Showed up.
It's, so if you look at the, yeah, if you look at the first part, that's where we have the document, where do we